We are in a transformative era for aircraft development. There's an increased level of globalization, and so the number of planes that companies need to produce and the speed with which they need to produce them over the next 10 to 20 years is going to accelerate dramatically. All of that is driving the trend towards increased production rate with or without composite materials. When you throw composite technologies into the mix, you now have a much more complex and difficult situation to address.
Customers are actually doing several things to really try and achieve higher production rates. For smaller parts where they're using hand layup, what FiberSim does in those cases is actually produce the manufacturing downstream data that's required to actually achieve a good flat pattern the first time, so you're not doing trial and error templating, and generate the laser projection data. For automated systems like large gantry systems for tape laying or fiber placement, or for articulated robotics arms that are typically used for tape laying and fiber placement as well, we're actually able to generate the downstream data, the engineering definition. The last thing that we do is actually eliminate the ambiguity. What we allow is an import of that definition back into FiberSim, and so they're able to actually address those issues that aren't known up front and pull them back into the design so that they can address them before going through the entire process of producing a manufacturable part. The other thing that FiberSim does is it has an open architecture, and it allows a designer to complete an engineering definition of that composite part or composite assembly, and then pass that downstream to the manufacturing engineer who's going to do the path planning.
One of the biggest challenges is giving design engineers the tools they need to be able to understand the impact of their decisions on production rate. Through our products, FiberSim and SynchroFit, we give engineers the capability to understand how certain design decisions, whether it be a composite structure, a unitized composite structure, or whether it be a complex fastened assembly, how their design decisions and those trade-offs actually affect production rate. The other side of it is really in the area of complex assemblies. So the decision of whether to create a complex unitized composite structure or retain a more traditional complex airframe structure is really a balance that needs to be struck between the needs of making parts that are going to be high production rate from a composite perspective, or from a composite sort of part level perspective, or high production rate from an assembly perspective.
There are really two things that we do sort of at high level that really benefit a design engineer. Our leading edge simulations allow somebody to set up what the manufacturing process is going to be and really understand how it's going to affect the design of the part. The second thing that FiberSim really does is allow you to understand what machine is going to be used and what the limiting factors of that machine might be. FiberSim actually will provide an automated way to go through and add those features necessary to ensure that you don't have machine stoppages, so that you can go through and produce that part at the fastest rate that you possibly can.
At Siemens Specialized Engineering Software, we are focused on innovation in aerostructures and principally in advanced fiber-based composite technologies and their integration into larger, more complex aerostructures. We were founded as Vistagy and acquired by Siemens in 2011, and we were really the first in the industry to offer specialized composite capabilities, and we were recognized as the leader in this field. The SES approach has three components to it. We take world-class expertise in aerostructures and advanced materials, combine it with specific process know-how from the aerospace industry, and create software products which embed these capabilities into engineering tools to create aerospace-specific software solutions. We have three products for aerospace focused on aerostructures development. The first is FiberSim, which is used for the design of composite materials. The second is SynchroFit, which is used for the design of complex assemblies and the integration of parts into those assemblies. And then the third is called the quality planning environment, which is focused on the inspection planning for composite parts or metallic parts that you end up producing as part of your manufacturing process. The recent transformation with the inclusion of a higher percentage of composite structure into aircraft, and now the need to be able to produce those structures at a high enough rate to assure profitability, means there are lots of exciting challenges. The trick is to incorporate enabling technologies that allow you to shift the learning curve and get to a higher production rate and a higher level of profitability as early on as possible in the development process. What's really exciting about the era that we're going through is that it's not just the engineering technologies, or you could say kind of the material technologies, that are really leading the way. We're also leading the way with the software tools that are used in order to be able to design these exciting products.